Okay, so welcome everybody. I see we have 28 attendees by now and 5 panelists. Where's the other panelist?
I invited Carl.
Willie is there twice. Oh, you invited Carl. Excellent. He should rename himself at some stage, but okay. All right.
I think it's kind of nice that he goes on that name.
So that he could pretend to be nice. All right, so welcome everybody. This is I think the 3rd or 4th of this webinar series that we have. And it's the first one that we're doing on Zoom. So we're trying a different platform. Hi, Carl, Willie, Carl. Anyway, so just to say that these seminar series are held every 2 months. It's usually held on the last Tuesday of the month at 12 noon Eastern Standard Time, or 6 p.m. Brussels time, or 7 p.m. Namibia time, which is where I am. And today's is obviously happening today. And then on the 26th of January and the 30th of March will be the next ones. And if anybody wants to give a presentation and discuss their work on those dates, please let us know. I think we're still waiting, still looking for people. So today's presentation is by Dr. Chun, and he is going to give us a talk about his experience on Ecopath from the Great Lakes, the Laurentian Great Lakes. And he is working for the USGS. I'm not 100% sure how long he's worked for them, but he basically looks at the anthropogenic stressors on ecosystems such as the Great Lake ecosystems. So I think that's all I have, and I'm going to stop sharing my screen. And then Carl, if you can, sorry, Carl. Chun, if you can share your screen and make sure that you're unmuted, then you can take it away.
All right. Can you see my screen and hear me okay now?
Yes, indeed.
All right, I'm start. Hi, everyone. I am Chun from United States Geological Survey, Great Lakes Science Center. I am currently a biologist there. So first, this map just to show you where the Great Lakes are. And for today's presentation, I want to first thank my co-authors and the funding and the data sources in past 10 years or so. You can see their names here. And because this presentation is US federal government work, so everything here is in public domain unless otherwise addressed. So feel free to use and distribute anything in this presentation. So for today's presentation, I will first give a brief introduction to our study ecosystem, and then I will talk about 3 of our projects and our outlook. So the Laurentian Great Lakes, or the North American Great Lakes, contain 20% of surface liquid fresh water, which is a very valuable resource. And overall, by the latest statistics from the United States, there are 1.3 million jobs associated with the Great Lakes. The economic is at a level of 82 billion US dollars per year, and fishing, including fishing. So fishing was about $2.2 billion per year. So just similar to all the other freshwater ecosystems, we have a lot of stressors, and we also have a lot of management practices. And I will talk through some of them in these slides. So at the very beginning of the 20th century, at that time, we had some problem of overfishing. So fishing was at a very large scale at that time, and a lot of native species actually were fished to depletion. And then later we have the invasive species, because if you want to talk about only one invasive species in the Great Lakes, that would be sea lamprey. So sea lamprey invaded the system and caused the collapse of many native species. So sure, on top of overfishing, one of them is lake trout is not totally collapsed, but it really was driven down to a very low level. Lake trout was the only dominant top predator in offshore open waters. So because of the loss of top predator, we had another invasive species coming and exploded in the 50s and the 60s. That is alewife. So alewife came in, and then the system was really kind of problematic. So managers that time started to stock salmonids in order to, on one hand, control the alewife. On the other hand, it was to create recreational fisheries. So during the same period, we saw the collapse of commercial fisheries because of overfishing and invasive species. We also had a sea lamprey control program and the pollution control programs. So later, in the 80s, we have another waves of invasive species. We call it the newer invasive species, mostly came in from what I think it's called Kashipian ecosystem from ballast water, including spiny water flea, zebra and quagga mussels, and around the goby. So these are invasive filter feeders that sequestered a lot of nutrient and the primary production at the bottom of the lake. And around the goby is a benthic feeder that is able to feed on zebra and quagga mussels. And at that time, because of these Great Lakes water quality agreement, we have these phosphorus and pollution control programs so you see a long-term decreasing trend of nutrient and prey fish biomass. So you can see a lot of quagga mussel, and we also see some recovery of lake trout. So I'll talk about that later. So then I want to talk about a brief history of Ecopath with Ecosim models for the Great Lakes. At the very beginning, we have two Lake Superior studies. I think both were led by Jim Kitchell, and Carl Waters was one of the co-authors in this paper. So at the very beginning, in the early, I think around the 2000, we had two Ecopath with Ecosim models for Lake Superior. And around 2010, we had another push of Eco-UE modeling. So first, we want to have one more tool in our pocket to support management decision making, which is a goal probably. I don't know we achieved it or not. And I think the advantage of using this modeling approach is to give a quick evaluations for how and why ecosystem changed at that time. And we had at the early stage, we had two workshops. We invited Philly and Rob to Michigan. And then we also had a conference at American Fisheries Society. So, well, we also had a symposium at American Fisheries Society's conference. So fast forward to today, we already have model for each of the 5 Great Lakes. And for some lakes, these models we have multiple models developed by different modelers. And we also, some of the models have been updated to address different questions. So here are a few challenges we face. First, people are skeptical about this modeling approach, or we can say it's like a cultural shock. First, they are questioning about why this equation valid, and we say, yeah, it's just math, and how to calculate B and the biomass and the consumption to biomass ratio for multi-stanza groups. That's also math, and people had a lot of questions about network analysis. So we had to explain. And people also had some question about empirical equations. They just did not like that because we, in the Great Lakes, a lot of times we already have those parameter values. However, foraging arena theory was quite acceptable and the people actually like that, possibly because these Professor Warner, so he is a professor at the University of Michigan, just retired 3 years ago. So talking about predation risk and habitat use. So basically how behavior of prey fish change with presence of predators. So foraging arena theory is generally more accepted. And then the other part of these challenges are associated with the data and our questions. So we had a lot of data and because we have a long history of monitoring. So we want to incorporate all of these data and the knowledges into the model, but it is not always feasible. And the other question is the species of interest is not in the Ecopath. So for example, we built an Ecopath model in the 80s, but we are interested in the invasive species. So these species may invade in the calibration period, or some of our stocked species become naturalized. So we are still stocking these fish, but some of these stocked fish, they started to reproduce. So that's how do you do that in the model? And what do we model potential species that, so other species that may invade these food webs. So the bottom line here, we say just to make the model address our questions, just don't make it perfect, just stay focused on the question. And if the model can address our question, we think it's a success. All right, so now you will talk about our projects and how we address those challenges. So the first project, I'm going to talk about the relative importance of top-down and bottom-up effects on the collapse of alewife in Lake Huron. So what happened? Well, sorry, so this is Lake Huron, and the Ecopath model is in the main basin, so not in the embayment part, the main basin of Lake Huron. And the ecosystem is oligotrophic, and in general, it's deep and cold. So you probably remember this photo in previous slide. There were a lot of alewives in the 50s and the 60s, but after the stocking of salmonids and the reduction of nutrient level in the system, the biomass just started to decrease, and suddenly in 2003, you don't see any alewife in the ecosystem. Well, you still see some, but really not that much. So there were two hypotheses. One is too much predation by stocked Chinook salmon, and the other is too much food limitation due to the nutrient reduction programs and the invasive zebra and quagga mussels that filter out too much nutrient and the primary production. So because there are a lot of data, so we were, at that time, we really did not have much experience. So we tried to incorporate all of the data we have. So we have a lot of groups in the lower trophic level, and including two groups for the microbial loop that are bacteria and the protozoa. And then we also have invasions after the Ecopath year, which is 19 1984. We have zebra mussel invaded in 1990, and the quagga mussel in the Round Gobi invaded around 1988. And some of the stocked salmonids become naturalized. So when I say stocked salmonids, those are mainly three species. First is lake trout. That is, they are native top predator and the restoration target. Lake trout looks like this. And the Chinook salmon stocked to create recreational fisheries, and they are favorite fishing target. And we also have steelhead or rainbow trout, and they are stocked to diversifying the fishing experience here. So it's a quick summary. The goal of this study is to understand the relative importance of top-down and bottom-up effects, and we will build Ecopath with Ecosim model for Lake Huron main basin to address these questions. And the general hypothesis, the collapse of alewife was caused by a combination of top-down and bottom-up effects. So how we addressed these challenges? So a lot of data. So reading discussion, like what we always did for any research. And there was something we needed to do is trust building, because a lot of data were provided. At that time, data were not that accessible. So we needed to build some trust to people who are actually collecting and managing these data. And secondly, and most importantly, we needed to acknowledge that we don't have unlimited time and money. So we can only build a model to address our question. So first thing first, and having clear targets before even building the model, because then you know how to configure your food web, and you don't need to collect that much data. So how do we model invasive species? So it's a quick summary. First, we have low Ecopath, low input biomass in the Ecopath model, and they use forcing functions to limit their trophic interactions until the invasion. So these are forced time series. So no trophic interactions until 1990. And then give them a forcing function to high search rates just to make the initial increase of biomass happen. So just to use different forcing functions to make that happen. And so that's our general steps to model invasive species. And how to model naturalized salmon. So we actually changed the source code so that you can actually have negative harvest at input. So you can actually input negative harvest time series, and we use this negative harvest time series as our stocked biomass, and it can be at age 1 or age 0, and after a certain period of time, you just give them these biomass to that stanza, and then and it will still recruit following just like how you model all the other multi-stanza groups. So the food web model, the food web in Lake Huron is like this. It is a simplified figure. Most primary producers, part of production went to detritus and recycled by bacteria, and then went through this pelagic pathway, zooplankton, pelagic fish to predators. And then a lot of production went to the detritus or benthic pathway, going through benthos, benthic prey fish to the predator. And then we have these invasive species. So a lot of primary production actually went to this pool, libra and quagga mussels, and just 10 or 20% of those were eaten by round goby, and the round goby was eaten by predators. So in total, this model has 53 groups because we did not know. Yeah, got to say that was not a very good decision. And then the second part of this study was the scenario simulations. So in Ecosim, we consider scenario simulations as a virtual full factorial experiment with 3 factors: Chinook salmon, quagga mussel, and the nutrient. So Chinook salmon from low to high level, quagga mussel from low to high level, and the nutrient also from low to high levels. So just a brief summary to the most important result. First, we look at 1 factor effects. So each of these points represent equilibrium biomass of alewife adult. So that means if you keep everything constant in a simulation, in a scenario simulation in Ecosim, at some point you will see the ecosystem reach another equilibrium. And so we are reporting the biomass of alewife 1+ adult at that equilibrium. So when we say 1 factor effects, we keep the other 2 factors at the median level. So first, you can see here with increase in Chinook salmon, you see a decrease of alewife biomass, but no collapse. Similarly, quagga mussel, and so decrease the biomass of alewife would decrease with quagga mussel, but no collapse, and also decrease in nutrient, and you also don't see a collapse of alewifes. So now we look at 2 factors effects. So first, you see Chinook salmon and the quagga mussel effects. So combined effects of Chinook salmon and the quagga mussel. You don't see collapse here. But when you look at the Chinook salmon and the nutrient, or quagga mussel and the nutrient effects, you start to see collapse of alewife biomass at a low nutrient level. So finally, this is the actual figure in the paper. You start to see the the combined effects of 3 factors, and then you can also see where were the food webs in different years. So in 1984, we see the food webs were at the food web was at this point: high nutrient, no quagga mussel, and a high Chinook salmon biomass. And in 2002, the year before alewife collapsed, you start to see, oh, well, if we had this model in 2002, we may see the collapse happen. So that, because at that time, the Chinook salmon was still at a high level, and we have median level of nutrient and the median level of quagga mussel biomass. So really, the collapse could happen if all the conditions maintained the same into 2003, 2004, and 2005. So after this study, we have 2 big take-home messages. So first, the collapse of alewife could be driven by a combination of top-down and bottom-up forces. And given current, so that's what we saw. Only 1 factor would not result in a collapse of alewife. And given current condition of low nutrient and high quagga muscle, Lake Huron may not support a high level of Chinook salmon biomass. So we can see 84 here, 2002 food web here. And the current food web is more at this condition. And we already see this is at equilibrium. So probably this equilibrium will run into the future. So you probably want to see a lot of Chinook salmon in the future. So that's the first study. And then the second study I want to talk about, we use this model to evaluate stocking scenarios in Lake Michigan, which is a lake undergoing kind of oligotraffication, loss in nutrient. And this was, we won Best Paper Award in 2018 because of this paper. So in Lake Michigan, generally similar to Lake Huron, but it has been more productive. So you can also see the same bottom trough surface and the same alewife biomass, but the same decreasing trend as you have seen in Lake Huron, but it did not really collapse. So they are still there at a relatively low level. And the Ecopath with Ecosim model we used here was originally developed by Rogers, sorry, missing an S, here in 2014. And we updated that for this study. So the model was like this. It's a 2002 food web. So you already can see the brown mussel and around the goby here. But we did not have that many groups in the lower trophic level, nor did we have those bacteria or protozoa in this model. I personally feel it's probably not necessary to have those groups. So the goal here is slightly different. Showing means showing managers and showing managers that Ecopath with Ecosim can be used to support decision making, and by evaluating the efficacy of salmon stocking. And we will again use a model, and stocking the general hypothesis is stocking different salmon species will give you different results. So the project started in 2015, and at that time we were already experienced. So this part, updating the model, was relatively easier. And the step forward here is to have managers and researchers engaged in the step of developing management scenarios. So what do they want to know? So here are the outreach. So these files show you our outreach effort. So have a planning, what do we want to say, what do we want to talk, how we want to talk to the managers and the researchers. We went to a Lake Michigan Technical Committee meeting to show our idea, developed a questionnaire to ask what they want, present our results, preliminary result, presented the final result, and asked Lake, kind of forget what this means, but these are Lake Michigan Committee, so managers, so these are scientists and managers, but mostly scientists. This is mostly managers, and let's see what they want. So, and then we had these responses and developed our scenarios. One thing we learned is that you don't really see the consensus. So some people really want to know salmon stocking. Some people really want to know effects of nutrients. So really there was no consensus And at the end, we had to use a lot of scenarios to address everyone's needs. So we have stocking scenarios for Chinook salmon, lake trout, and the steelhead, quagga mussel consumption, high and low, and the nutrient, again, 3 different levels. So this is our result, this for Chinook salmon, and it is also slightly complicated. So I will walk you through these. First, we see effects of increase in total phosphorus. Basically, the biomass would increase with increases in nutrient. So this is wild group and the stocked Chinook salmon. So we just separated them. And the increase here. And then when we have more quagga mussel, then the biomass of Chinook salmon will decrease. However, when we increase the stocking, you can see decrease of wild Chinook salmon, but increase in stocked Chinook salmon. So overall, that's not too much change unless you completely eliminate the stocking program. Finally, these arrow bars are for the stocking scenarios of other salmonids, which are lake trout and steelhead in this case. So you can see you really did not see much effects of stocking of those species. And the results for lake trout and steelhead are slightly different. You still see increase with nutrient, but they did respond to our stocking scenarios in the model at least. And also you see slightly positive effects of quagga mussel. But once again, you don't see strong effects of stocking of the other salmonids. So stocking of other salmonids is once again arrow bar. That's really did not make much difference in this case. So after this study, we try to make our results really simple and present these results to the managers. So they are like this. We have a longer list, but these are more representative. So will decrease in Chinook salmon stocking resulting in decreases in Chinook salmon. So 50% decrease, probably not much. But if you completely eliminate the stocking program, that could be very problematic. You will see decrease. So while decreases in stocking of lake trout and steelhead lead to increases in Chinook salmon, the results showed no, that probably won't happen, and you will lose lake trout and steelhead. So the main reason is very well summarized by this Chicago Tribune newspaper reporting our study. Well, so because lake trout and steelhead are switching to, so they could switch to feed on both alewife and round goby, while Chinook salmon were still feeding on almost solely on alewives. So you can see the decrease in alewives, but they really could not switch to use the more abundant prey resources, in this case, round goby. So finally, we have our latest study talking about how to address bighead and silver carp's effects on the Great Lakes food web. So we really do not have these species in this ecosystem. So it's really totally hypothetical. And so this will be quick. So bighead carp, which means bighead and silver carp, And both of them are filter feeders introduced for water quality control, but they managed to escape the water to the rivers and started to spread in the Midwest and Mississippi River region. So the invasion front is in the Illinois River. It is very close to Lake Michigan. And because of this jumping ability, so you see this scary image of silver carp jumping. So they are arguably the most well-known potential invasive species here. And the goal here is we want to use these models to project big-headed carp's population, biomass, and the potential food web effects across Great Lakes habitats that differ in productivity and species composition, or basically where we already have Ecopath with Ecosim models. So we use standardized procedure we use the standardized procedure to implement these 4 Ecopaths and the Ecosim models. These models are Saginaw Bay, Lake Erie, Lake Michigan Main Basin, and the Lake Huron Main Basin. So the hypothesis is also simple. The biomass and the effects of big-headed carps will differ among lake habitats and will be correlated with productivity. So these are our modeled ecosystem: Lake Michigan Main Basin, Lake Huron Main Basin, Saginaw Bay, and Lake Erie. And these ecosystems are different mainly because of their trophic states. So Saginaw Bay and Lake Erie are more productive, but Lake Michigan and the Lake Huron Main Basin are not. And we have different ecopath period, or these models were already available to use. So at this time, we were already very experienced. We already have 7 papers published using these Ecopath with Ecosim models, and a lot of trust from our colleagues. It is good and bad. We can talk about more later, but generally it is better to have a lot of trust than not. So this is a brief procedure about how we model a potential invasive species. So at the beginning, again, low biomass. So the assumption is 2% of total fish biomass in each food web. And the Ecopath parameters were mostly from expert opinions and the literature. And the vulnerability parameter values were borrowed from the dominant existing planktivores. And finally, to address uncertainties, we used the scenarios. So there are scenarios of high and low mortality rate, high and low vulnerability, and with or without predation by salmonids. So basically 3 factors, and each of those has 2 levels. So I only have 1 slide showing the results and the big take-home messages. So so let's look at the result first. So you can see there will be a difference across habitats of different productivity. You could have more big-headed carps in Saginaw Bay and Lake Erie than in Lake Michigan and Lake Huron Main Basin. So when we look at the most likely scenario, high production to biomass ratio, high vulnerability, and no salmon consumption, you can clearly see the difference. So what does this tell us? So two things. First, with a 2% initial initial biomass of 2% total fish biomass, big-headed carps might establish in all of these four habitats. So even in the more cold and the oligotrophic waters, you may still see them establish. This could be an artifact, but our model did not say it. They won't. And then the effects are higher. In effects of big-headed carps are stronger or higher in more productive habitats. So this is really the big take-home messages. I only have results. Yeah, I don't have more results to show because it's a really long study and I don't feel those are as interesting. So all the studies, all of these, the projects I presented are already published. If you want to know more information, you can ask me and I can send you the paper to read more details. So here, finally, this is my last slide. What we learned in past 10 years, we definitely, at least I definitely think it is another useful tool. People are maybe skeptical about that, but it will not stop here. So we need to do better with our communication or do more study, do better presentation to convince them this is another useful tool. And secondly is first thing first, we don't have unlimited time and money. So just address the most important questions. And some experience about science communication. In USGS, this means publish paper. So need to have a research hypothesis. So a lot of times we saw these Ecopath, especially Ecopath papers, they just reported the Ecopath summary statistics without a research hypothesis. So this is a big no based on my experience. And then the second is to well explain Ecopath with Ecosim terms and what do they mean. For example, a frequently used term is ecosystem maturity. And it was also not well accepted in my experience. So what does that mean? What does that tell us about ecosystem management? Do we want to pursue ecosystem maturity? How can we pursue that? Does this also mean more fish? So there are a lot of things associated with this. You can, if you just go there and say our model show this ecosystem maturity is decreasing over these 10 years, it is usually not very good. And our main challenges to date, I think, in my experience, first, it is a relatively closed circle. One of our colleagues call us the club. This is good. We have a lot of trust within the club, but we also don't have much interaction with other modelers or other UE users. A lot of people probably don't even know we have built these many UE models in the Great Lakes. And the second is a continuation issue. I don't know what's the model in the other part of the world, but in here, we usually have a graduate student or a postdoc modeler advised or supervised by a senior ecologist. So ideally, we want to have a modeler, and the modeler is also an ecologist with a good understanding of the ecosystem and the data. but we don't usually have that. And a lot of times our senior researchers, they don't really know how to use these Ecopath with Ecosim models. So, graduate students and the postdocs come and go. Once they left, we have these continuation problem. So this is my last slide, and I am happy to answer questions. Well, do I have, oh shoot. Yeah, so we had this just came in last Friday, and so we used the Ecopath models as an outreach material. I will put this in chat. I welcome everyone to take a look. So I'll leave the slide here and ready for any questions.
Thank you very much, Chun. That was great. It's always good to see what's happening in the freshwater field. So it's nice to see that you guys have been doing this. And you're right, it is a little bit of a club because we don't, well, maybe Willie and Carl have done more with the freshwater people, and Lee, obviously. But from the marine side, we tend to be a little bit salty in our approach. So we don't tend to probably read as many of those papers as we should. So I think we have at least one question in the questions and answers, other than the one about the possible next Ecopath course. But David Richards says, I'm a very good ecologist, but a mediocre modeler. Hopefully courses, collaboration, trial and error will provide fruitful outcomes in the research. I'm leaning on wetlands in the Great Salt Lake. Any suggestions? My suggestion is you should speak to Chun, quite frankly, and Lee, I would imagine. Do you have any suggestions for him, Chun?
I actually don't know whether Philly is offering another Ecopath with Ecosim course.
Yeah.
Because that was really a kickstart of my modeling career. I went to Vancouver to learn this model in 2009. So, well, we may have met each other, but but that was very helpful. Other than that, I think you really need to spend maybe at least a week to learn how to use this model.
Oh, I would suggest more than a week, but
Yeah. Right.
Much more than a week. 30 years is what it's taken me.
No.
I don't know, do anybody else want to add some advice? We've got 2 more questions, so we could go to those and then come back to that. Willie, did you want to say something? Willie, not Carl, Carl, not Willie.
So, Carl, what do you want to say?
You have to unmute yourself first, Carl.
Well, maybe I can answer a little bit. So, the fellow working on the salt marshes at the north end of the Great Salt Lake. Now, been hunting there back in the day. Yeah, you're going to have to ask Billy about the future of courses related to that kind of thing. As Sheila says, you don't go to a 3-day or 5-day course and then figure out how to use that software. The software, particularly the newer versions, is really challenging. I can't use it, right? And I helped really develop the original software back in the day. So you need 2 things. You need somebody to guide you through all of the outrageous front end of it and the definitions and all the terms and so on like that. And then you really need to sit down, as Chun said, and really think through exactly what it is that you want to model, because you can end up spending months and months and months and months putting in all kinds of details that just don't matter. The classic one in many of these cases is you got to have the microbial loop, right? All this complicated microplankton stuff, but it's never ever made a difference to any of the models, to all of the time that it takes to do that. You can waste a huge amount of time. And when you're looking at something like a salt marsh ecosystem or experience with those things in Louisiana, with people at LSU developing salt marsh type models is that you really got to watch out about edge structure. The foraging arena structure idea of hiding places and exposure places where organisms interact in a very restricted space, part of the overall space, is really crucial in how those systems behave. You always be thinking about it visually, not just mathematically.
Thank you, Carl.
If I
Yeah.
can just add that,
Yeah.
I think the one major advantage of the approach here is that it's fairly easy to get started. So it's a fairly flat learning curve, but the road ahead is very, very, very long. So it's a very long hill. And yeah, it is. There is so much hidden in it, and it's very capable. And there's so many ways to trick it. So one good approach is to play with the models. And you should, I like your presentation, and I like that you figured out to use negative catches to do stock enhancement. And indeed, when you're looking at invasions, there are a number of different ways of addressing them, and playing with them and trying different things is definitely the way to go, because the way the model is put together means there's difference between applications. So it means there isn't just one way of doing things. Different things may work differently, and one has to try it. So play with the models. And as Carl pointed out, it's really dangerous to try to see, I want a model that describes the ecosystem, has everything in it, and spend years making that complicated model before even starting using it for a purpose. The other approach of making minimal realistic models or mice model type, which can easily be done in EWE much quicker, is a much more sensible way of going about it, and then adding complexity where there are things that you can't explain that you need to consider, make it more complex at that point only. But it is a long road, and it does help to get an idea about what the model is doing. So actually read about it and think about it. And then there are lots of options here. Carl, Carl/Willie.
Yeah, let me just add a thing about that. One of the things we point out is that very often the main things you learn from the model, you learn while it's failing. Well, it's not doing what you expect it to do or want it to do. So that process, it's not wasted time. That process is an incredible learning process. So it's a question about the presentation today along those lines. I saw something that didn't look right to me, that I didn't expect, and that was the effect of increasing Chinook stocking. In the first model. So the Chinook abundance dropped down, back.
This one?
Yeah. Why does the Chinook salmon flatline? Why does that? Why does that Why does the alewife stop declining when you get up to high Chinook abundances? Why isn't there a monotonic decreasing relationship there? Because there's obviously it's hitting a threshold where the Chinooks can't do any more damage.
Right.
What's doing that? Because that's not part of the Ecosim structure.
Oh, really?
I don't know. I mean, I've never seen one do that. But
It's a compensatory predation, Carl.
I think that's what.
No, it's the other way around. You're increasing predator numbers, and all of a sudden the prey stops.
Oh, then they go up. Yeah, it is the other way around. Yeah.
So it looks like what must be going on there is you must have the prey reaction to predation risk thing turned on in the group info tab, so that alewives are becoming less available as predator abundance increases. They're reducing their foraging time or something. I can't see. I've never seen that pattern before.
Well, when we Oh, that's interesting. Well, but what we did here, I thought that's the result of probably because of the forced biomass. Because when we have these are not simulated, these are scenarios. So each of the point is actually a forced biomass of Chinook salmon in the simulation. So even you forced the Chinook salmon to a very high level into the simulation, you want to see that high level of Chinook salmon eating all of the alewives.
Oh, I see. So it's something to do. But are you forcing biomass or forcing the stock?
Forcing biomass.
Oh,
Yeah, so I think that's what Foraging on Rena tells us. Please don't tell me I'm wrong. It's already published.
well, yeah, I'm not sure. It puzzles me.
So if I can try and see if I understand what this means, are you saying that you had on the x-axis so many salmon, and then it predicted so many alewife, and that didn't change until a certain point where all of a sudden, when you had less salmon, you had more alewife? That's what you're saying, right? You're forcing
Yes.
the salmon and predicting the alewife. That's
Right.
what this graph is saying. So basically, from, I can't really see the bottom. Yeah, so from in the purple, without any muscles, from 0.1 to 0.2 grams per meter squared, there was really no difference in the number of alewife because it didn't. Yeah.
Right.
So there wasn't. Yeah. So I mean, that's what I'm understanding the graph to say, but I don't know if that makes sense about it.
Did you have prey switching?
Yes, I tried not to change any of the default settings.
So then there shouldn't be any prey switching.
Well, actually,
Right. Sorry.
if you have a fairly low vulnerability multiplier for alewife to Chinooks,
Right.
then the maximum mortality rate that the Chinooks can exhibit becomes independent of Chinook abundance. But
Oh,
usually
exactly.
that transition is smooth, I thought. Not that really abrupt threshold thing.
But you are right here. In our calibration, surprisingly, in different this is true in both lakes, Michigan and Huron. You see very low vulnerability for Chinook salmon. So Chinook salmon as predator.
Well, I'm not sure if we're going to resolve this question, but we've got very little time left. So I might want to try and ask some of the others, and then you guys can try and resolve this conundrum. Yep. So we have a question by David Brown saying, and it goes back to the statement that Carl made in 1992 about not being able to use these models. And then he says that Steve, with the book with Steve that he published, it included 3 chapters on food web modeling. So the question to you was, did you go back to the managers with your Lake Michigan model, and were the results appreciated?
Oh, so in general, they like these results, but how much the results go into decision making, we are not very sure. The management decision making was mostly still based on single species or multi-species population model, but I think people are aware of this method, and hopefully it will be more widely used in the future.
Thanks. And then Jason Stockwell asks, what processes did you use to build trust with data providers? That's a good question, Jason.
Yeah, at the beginning, it was very hard, but since 2012, 2003, President Obama signed an order or whatever it was. So now all the federal, if you are using federal funding to collect data, those have to be freely available, and we have to make effort to make those data available. So in general, if those are federal data, they should be available or online. If not, and you just need to file an application or say, I want this data, and you will get those. And for the states, it was a longer process, still mostly going through the network. But in general, it has been much easier now than 10 years ago. I think people are more aware of the importance of open data.
Okay. Then we have a question from Rosalie Bruel, who says, you mentioned the models of stock species that later become naturalized, the salmonids. So how do you model this naturalization? I think you answered that question, but maybe you want to just recap.
Right. So basically, the stock species are modeled as multi-stanza, and then multi-stanza you can have you can just change the source code. Maybe these two something to consider in the future, in the next version, so that we can just enter a negative harvest. So in a stanza where you want to stock, and that's the biomass into that group. So and then it will recruit just like all the other multi-stanza groups.
Okay, thank you. I think that's a great idea. It's definitely something that the Ecopath modeler should think about. Then Apendra Bele asks if you used other tools such as Ecospace. Have you ever used Ecospace in your modeling?
We are not. I think that was also at this point, but we are thinking about that. We just don't have a very good question at this point to trigger that need. And the other thing is, when we want to use Ecospace, we also want to have a finer time step, current temporal resolution at a monthly level. Probably not very enough if we want to go to the Ecospace level.
I spent the weekend on making a model for an estuary here this last weekend, and that was with including tidal movements. So the time steps were down of the order of, well, in that case, it was half a day time step. The next iteration of it is going to be 2-hour time steps and full tidal movements. So one can trick this. That's what comes from when I was talking about playing with the models. And Ecospace does have variable time step. It only messes up if you want to use temporal spatial data. Then you have to stick to time step that is 1/12 of like monthly time step and annual rates, or daily time step and 2-hour rates. It's also quite feasible. So one can actually play with these things.
Thanks, Willie. And then we have one last question, and this one is actually for everybody. And that's from Joe Mrak. Sorry, I'm not pronouncing your last name right at all. The question is that he's not seen so many Ecopath papers in traditional fisheries journals, like the Journal of Fish Biology, Fisheries Research, Canadian Journal, and so forth. And the question is, do we see that changing in the future? And do we foresee an Ecopath with Ecosim specific journal coming out? I say no, but that's just me. So I don't know if anybody wants to, I don't know if you, Chun, if you want to have a go.
Yeah, I probably have the answer to why we did not publish on traditional fisheries journals. Sorry, at early career, you target high impact factors. So for some reason, those, but I think on the marine side, you probably see more papers published in marine journals. But for freshwater, yeah, I think that's because our questions are, we feel that's more broad, and we want to publish on journals with broader audience. However, we did have 1 or 2 papers on traditional fisheries journal. This one, sorry, So the Asian carp paper was on the North American. Where is so? Sorry, I'm sorry. So this one, this one is on Canadian Journal. Sorry, Canadian Journal. Yeah, this one is on ecosystems. This one is on North American Journal of Fisheries and Aquatic, NAJ. Yeah, so this one is on North American. So these two are on Fisheries Journal. These are on Ecological Modeling, Journal of Great Lakes Research. So I would say it's a mix. So really, it's yeah, and this one is on transaction of AFS, and this one is on biological infections. So I think really it's a mix, maybe half and half.
Yeah.
Can I just mention, in October, I spent half a day just extracting 2019 and 20 Ecopath, or was it just 2020 Ecopath publications? And it was something like 100 that came out of that. Maybe it was 2019 and 2020. I was really surprised. And there was a lot of diversity in journals as well. Ecological modeling is still the major one, but certainly a lot of diversity. And in bracket, I can mention, I have about 900. And if anybody wants the link to download them, just send me an email.
Thank you, Willy. Yeah, I think the fisheries journals tend to be very specific, and as Willy says, a lot of Ecopath publications tend to be published in ecological modeling. That was definitely the go-to way back when I was still publishing loads of these things. But I think that it's, Willy, you're right. There's quite a wide range of journals now. Now I want to also come back to the discussion about the next Ecopath courses. So Natalia Serpetti has had to leave, but she was saying that from her side, I used to teach a course in Scotland, then she took it over and she was teaching it, but now she's not there anymore. But she will, if she can go back to Scotland for a course in March, there might still be a course, but I think the chances of there being a travel being possible in March is relatively unlikely with COVID. So that course probably won't happen in person, but there might be an Ecopath course at the ICES conference in September. So those are the two that we know of. Willy in the chat had mentioned that he is doing an online course as of January. What did you say, 2 hours a week or something like that?
Yeah,
and
two
I'm
times
guessing
2 hours a week, yeah. Tuesday and Thursday mornings, most likely, 10 to 12 Pacific is the plan right now.
And that's for the whole semester?
12 weeks.
12 weeks, okay. So those are the courses that we know about at the moment. I don't know if there's any others. And I don't know if anybody else, if there's any. There was a question in the chat about whether you'll make whether you'll announce the course, Willy, and I see that you will post it on the Facebook page in December. So, and can that be, anybody can take it? Are you teaching it for UBC and you can have extra people? Is that how it works?
I'm trying to sort that out with UBC because of course there are UBC students that are paying to participate in the course, but I would like to make it more open. One possibility is that we do like this, that those who are registered at UBC are panelists and attendees can listen in and write in. That maybe UBC will accept something like that. General UBC is great to work with, so I'm sure we'll find a way of doing this.
Thanks. Okay, I don't know if there's any other questions for Carl or Willy. I'm not sure if we've lost Lee. She seems to be not there anymore. So if there's any other questions for anybody else, now is your last chance. Oh, there was a question about whether the recording will be available. Yes, it will be available on the Ecopath website if anybody wants to watch this again. I just need to save it once we've finished here, and then we'll have it online on the Ecopath website. So I don't know if anybody else has any more questions.
Presentation there too?
Yes, Chun will have a copy of the PDF, a PDF of the presentation. Is that okay?
Oh yeah, it's already approved to you.
Okay.
Yeah.
Yeah, so the presentation will be there as well. And we will, if anybody wants to give a talk in January, I think January, please do let myself or Lee know, and we will set it up for you guys. And yeah, I mean, these things are great, so we should definitely keep it going.
I'm suggesting that we do make a Carl Walters foraging arena talk.
Oh yeah, I think that's a great idea, if Carl will do it. Carl is ignoring me as usual.
Willie Walters will do it.
Willie Walters will do it. Excellent.
You want me to give the standard foraging arena talk? I'm going to have to give it in his class, so just make sure you get.
Record it.
Yeah.
I mean, how many? I have to give that every year for Billy.
Yeah. And I think it'd be useful for to give it to a broader audience.
Yeah, I think that's a great idea. Excellent. Thank you, Willie and Carl. Thank you very much, Chun, for giving the talk. It was great. It was wonderful to hear what's happening in the lakes. And yeah, hopefully I'll see everybody again in 2 months' time. So.
Thank you.